Now, quadratics are very useful in helping us to solve some problems because a lot of the things we observe in nature follow a pattern built by a quadratic. For example, gravity, a ball thrown on up and lands, that models or follows a quadratic or a parabolic path. One model that we use a lot models how high an object is after a certain time. So I have some building, I'm standing on top, yeah, that's me. I took a ball and I threw it up and it came down and landed at the bottom. And I was curious, well, how long was this object in the air before it hit the ground? Well, that path can be modeled by this function that I have right here, where h is the height of the object, and it's a function of t, so minus 16t squared plus 48t plus 160. So the question I have is, at what time did my height equal 0? So here's my model. I'm going to set the height equal to 0 and then solve the quadratic. So let's factor that quadratic, and I'm going to factor it by factoring out a negative 16 first. Then what's left? T squared minus a 3t minus a 10. That's still equal to 0. I can factor this trinomial. It factors into a negative 5 and a positive 2. For this to be true, then I have to set either t minus 5 has to equal 0 or t plus 2 has to equal 0. I don't worry about the coefficient setting that equal to 0 because negative 16 can never equal 0. I'm interested in the terms of the variables in it. Solve that for time, or t equals 5, or t equals negative 2. And there's my two solutions for this quadratic. Or are they my two solutions? What do you see as a potential problem here? I cannot have a negative time. 2 seconds negative doesn't make sense in this particular problem. Mathematically, it makes sense, and I'll try to show you why here in a second, but in physical world, it doesn't make sense. The time of 5 seconds does make sense. So this tells me that the flight of my ball was in the air for 5 seconds before it finally hit the ground. Now, this other negative 2 that we got, you'd have to imagine a little bit because this path follows a curve. And mathematically, this path has the other side of that curve. And that curve, if I went backwards in time, kind of, and followed the mathematics of that curve, it would come back down and hit the ground there 2 seconds beforehand. And so, but we'll throw that result out because we're looking for a result that makes sense in our time, in our dimension. And that means it's a positive time. So 5 seconds after I throw the ball is when it hits the ground.